In this video, we're going to go through some examples of reversing the chain rule similar to the previous video. Okay, so what we've got in this first one, we've got the integral of x times 5x squared minus 1 cubed. Now, we can see that the derivative of what's inside that bracket is 10x. Outside we've got 1x. So we've actually got a multiple of the derivative of what's inside that bracket. And that's what's going to allow us to use reversing the chain rule. If it wasn't there, we couldn't use this approach. Okay? So we would then be expecting the integral to be of some format of 5x squared minus 1 to the power of 4. So if I differentiate that, I should be able to work out what that coefficient is in a very similar way to what we've been doing before. So the derivative of the inside is 10x. That multiplies with the 4 to make 40x. And I've got the 5x squared minus 1 to the power of 3. Okay? So we've got 40x times 5x squared minus 1 cubed there, and we've got 1x 5x squared minus 1 cubed there. So we've actually got 40 times too many of what I need. So this requires to be 1 over 40 lots of the 5x squared minus 1 to the 4 plus c in order for that to differentiate back to that. Okay? So that's what I need there. Okay, let's have a look at number 2. 3x times 4x squared plus 5 to the 5. Okay, similar approach then. So we've got the 4x squared plus 5, and we'd be going up to the power of 6 this time. So if I differentiate that, then I've got 8x coming from the inside, I've got the 6 coming down, so I'm going to have 6 lots of 8x, so 48x, 4x squared plus 5, drop 1 from the power, and so we'd be at that. Now, what have I got? Well, I've got 48 there, I've got 3 there. So I've actually got, what, 16 times too many? So what we'd be looking at is it's that 3 over the 48. So 1/16 of the 4x squared plus 5 to the 6 plus c, in order for that to differentiate to that. Because we know that this 4x squared plus 5 to the 6 differentiates to this. So 1/16 of that will get me the 3. Okay? So that's number 2. Right, let's have a look at number 3. So we've got the 8x, 4 plus 3x squared to the 3rd. So we'd be expecting it to be 4 plus 3x squared to the, add 1 to 1/3, 4/3. Okay? So if I differentiate that, so d by dx of that, I'm going to have the 6x coming out, and the 4/3 comes down the front. So 4/3 times 6x. So 24/3, so 8x. And then drop 1 from the power. That is right, isn't it? Yes. Yeah, that's fine. Yeah. Just doubting myself. Right. So what have I got there? I've got 8x, 4 plus 3x squared to the 3rd, which is actually precisely what I've got here. So this one actually integrates straight to 4 plus 3x squared to the 4/3 plus c. Okay? So that one, we didn't even have to worry about that fraction at the front. That one's all fine. Right, last one then. Integral of 6x squared times x cubed minus 2, all to the power of minus 6/5. Right, okay, so let's look at the x cubed minus 2. Add 1 to the power of that. So minus 6/5 plus 1 is minus 1/5. And I'm going to differentiate that. Okay, so 3x squared will come out. The minus 5th will come down the front. So minus 3/5 x squared times x cubed minus 2 to the power of minus 6/5. Okay? Now, the fact that we've had x's and x squareds there, and now an x squared, x cubed here, is the fact that it's still perfectly valid to work like this, where I've got the a multiple of the derivative, what's inside, outside. Okay? So now I've got this. Now it's a little bit more fiddly to figure out what fraction I've got and what needs to go in front. But if we remember back up to this one here, okay, we had, what was it? We had 48x at the front, if I remember rightly. So we did 3 over 48, made the 1/16. So if we use the same trick, 6 over minus 3/5, okay? So 6 divided by minus 3/5 is minus 10. So minus 10 lots of x cubed minus 2 to the power of minus 1/5 plus c. So, just to confirm that this differentiates to that, we've got the minus 10, the minus 1/5 comes down, multiplies with the minus 10 to make positive 2, and 3x squared comes out. 2 lots of 3x squared is 6x squared, which is what we have there. So these are the 4 answers that we'd be expecting using reversing the chain rule.